So welcome everyone to this week's IVI Coffee&Talk. We're delighted to have Dr. Fabiano Pallonetto here to speak to us today about AI and how it can support the decarbonisation of society. So I'll hand over to you, Fabiano.
Thanks a million, Grace. I hope you can hear me fine.
Yeah.
And thanks for taking some time to listen me talking about this topic that is quite an hot topic, but I think it's important to discuss also this sort of on how the artificial intelligence, how machine learning, how the data can really support the decarbonization of our society. I have a lot of slides of that, but I think I will be a sort of quick 20 minutes talk maximum. I don't want to, I would like to have a discussion more than, a sort of me talking about my research, and that's it, my research and what is going to happen in the future. So basically, within the Innovation Value Institute, I support, the sustainability cluster. And within this, the Innovation Value Institute, I think that is important that we discuss about energy sustainability and how we can contribute to the decarbonization of our society. However, the work that I do is not, a work that is standalone. I'm part of, and here is my note actually, I'm part of this proposal that has been, is going to be funded in the next few months. It's called Nexus, that is basically Next Energy System. And together with the UCD Energy Institute, we are working toward create an integrated approach to energy system, integrated approach toward net zero. As you can see, decarbonization is a very important topic nowadays. On the left of these slides, you can see that there are, the big contributor of like China and the United States of anthropogenic emission. And there's been a sort of rapid increase over the last years in the number of governments that are pledging to reduce greenhouse gas emission to net zero. However, the problem is, and there have been some progress in fairness. If you can see from 2010, to the latest data available, there's been a sort of increase in share of renewable energies, and also a decrease in primary energy intensity, and so on and so forth. However, we need to say also that the pandemic has provided a huge impact to the reduction of carbon emissions. So now with the next economic phase, we need to see where we will be at. Basically, however, there is still a long path to go. Think about that if you can see here the temperature increase since the last century, we are here, and in a sort of policy, normal policy scenario, we are going to reach an increase in temperature of 2.5, while the announced pledge scenario by the government will just assess the increase of temperature above 2, while a sustainable development scenario should limit, or a net zero scenario should limit the increase of temperature between below 1.5 if we want to reduce the impact of climate change. However, this is not a simple task at all. It's a task that is very complex and includes quite a lot of stakeholders. like household, community, transmission system operator, distributed system operator, and so on and so forth. Also there are a lot of stakeholders that contribute to anthropogenic emission, but there are also, among the stakeholders, there are also different type of industrial and different type of sectors. For instance, here you can see that, you know, the energy use is affected by the industry, the transport, like 20%, almost 16.2%, energy use in building, and then there is agriculture, forestry, there is waste, and there are the chemical industry, and so on and so forth, you know. So it includes all the aspects of our society. If we go and we look at Europe more in particular, we can see that, you know, the energy flow in millions of tons equivalent of oil, you know, is divided, you know, of course, there are quite a lot of transformation and distribution losses, but, you know, the main player, the main energy sector that take energy consumption are transport, residential, industry, services. But still transport, residential, and industry are the main one, with transport be at the top of the scale. So how we can achieve the decarbonization? Well, for sure, we can push people to change behavior, but also we can have low carbon technology with an active involvement of consumer, and we can have low carbon technology and renewable energies that could play an important role. However, you know, this talk is focused on the contribution of machine learning on data, on the decarbonization of our system. So let's try to briefly face these three main sectors, to discuss about these three main sectors and how the AI in particular can provide support in the decarbonization. The first sector that I would like to chat about is the transportation. That is one of the most important. How we can reduce the transportation activities, how we can increase the vehicle. These are the four means that allow us to reduce the carbon emission from transportation. So increase the vehicle efficiency, reducing the carbon impact of fuels, and shift into lower carbon option like rail or micromobility and so on. These are the four elements and the 4 points that make it very important. In terms of make the decarbonization of the transport sector feasible. So reducing the transportation activity, first of all, in this sort of case, it's important to understand the transportation data, model it in advance, and try to find alternative to transport. In this case, in this sort of context, you know, we need to discuss about sensor and IoT. Classification method can allow, like SVM or neural network, made quite easy to classify road with similar traffic pattern. Or they could also reduce the or improve the maintenance of the vehicle, of the road itself, but also the high resolution satellite images can have high accuracy, can serve and can help to estimate average vehicle traffic. Same things for machine learning methods that can basically complete the picture of emission, of bottom-up estimation of emission. And they could be applied to simulation models or vehicle emission models. And also in terms of mobility pattern, machine learning can provide, and artificial intelligence can provide information about using agent-based travel demand model, or you can estimate origin destination demand from traffic. You can use them to basically bundle together the demand and optimize the sort of satisfaction of the demand. And then we have accurate road traffic modeling, forecasting, that is always important. And one thing that we need also to highlight that, you know, during the pandemic, we have experienced how virtual communication is very important. We are able now to have a meeting in our location, you know, and this talk, we can assist to this talk even if you are comfortable at home without spending so much fuel because of these advanced models and these advanced data efficiency data to communication system. And the pandemic has really showed this sort of contribution. And in terms of increasing vehicle efficiency, we have seen lately that, you know, the number of electric vehicles in Ireland, but all over the Western world, is increasing dramatically. You know, this is this graph shows the number of units of electric vehicle in Ireland, and also we need to think about, you know, that we are electric vehicles are very complex, and they use quite a lot of technology and especially models in order to optimize the use of the battery, but also, you know, to reduce the impact of charging on the status of health of the battery. And then they're much more efficient than, you know, usually ICA vehicles. However, this is not yet, we are not yet there. You know, there is still a lot to do. If we think in the future, you know, we will have in the future, in the close future, we will have autonomous vehicle that will allow us using image vision, complex artificial intelligence algorithm will allow us to basically reduce further the impact of transport on the carbon emission of transport. One example that I'm working on at the moment on that is predicting parking behavior. Predicting parking behavior using sort of advanced machine learning model. Why is it important to predict parking behavior? Because if you think about in a scenario where there are electric vehicles, then you know, you need to understand when the vehicle and how much energy this vehicle are going to charge during their parking state, and also if there is a possibility for the vehicles to provide flexibility, to provide energy while they are parked, and not only to drain and to use energy. That's why, you know, we used an advanced algorithm that use computer vision to identify parking slot, identify spatial feature within the parking slots, and evaluate what are the occupancy and the forecast parking demand. So we can also, we can evaluate when a vehicle can, how long a vehicle will stay parked in a parking slot and when it will leave, so we could optimize the battery, the charging profile. So EV in the transport sector is part of the solution, and they have both a technological and energy network impact, and economic impact, and environmental impact. And these are some results you can see in the link. So If you think about transport, thanks to the artificial intelligence, the future will be accessible and inclusive, will be connected, autonomous vehicle, parking, they will need data. And they will need to understand, the algorithms will need to understand, you know, how long the car will stay, what we will do later on. They will do forecasts, they will be MPC, model predictive controller algorithm that will shape the energy profile of a parking lot. Will be multimodal. We didn't discuss about it for a matter of time, but you know, the idea here is that you don't have to use the car necessary. You can use cycle, you can use a small vehicle like scooters and so on. But the most important part, the most important contribution that the AI will support the sustainability of transport is that will be built from the ground up. So the consumer will shape the next sustainable transportation mode. Another thing that I would like to discuss today about very briefly is about the Global Power System Transformation Consortium. That is a consortium that I'm involved in. It's a global consortium that I'm involved in. And basically what we are trying to do, we are trying to empower area that have called low data settings area. There are, you know, area in the world, you know, or developing countries that they don't have the whole data set, the whole data and the whole sensor that we have in a Western country. So together with this Global Power System Consortium, we are trying to use to transport and to move tools, data, and open data and models towards these countries in order so they could apply the same algorithm, the same advanced techniques to decarbonize the power system. In this way, you know, we have developed several software that have, you know, they provide a framework to support the energy transition, and they are also open, and they allow also the integration and the sector coupling and the integration with forecast of flexibility, and for energy flexibility, I mean integration of renewable energies. And together with integration of renewable energy, we need always to consider forecast of the weather, forecast of the demand, and so on and so forth. Of course, the system is becoming very complex. You know, we have generation on one side, we have transmission and distribution of the electricity on the other side, then we have the residential, and we have commercial and industrial premises. In all of these elements of our cities, of our electric system, there are support, there are space, and there are application, very important application for machine learning, artificial intelligence algorithms. For instance, you know, in the generation system, you know, if you think about renewable generation, we already discussed weather is an important sort of variable. And so forecasting critical weather pattern is fundamental to ensure the safe and reliable generation of electricity. The transmission and distribution system, we use anomaly detection to evaluate, to forecast eventual occurrence, eventual events, destructive events into substation or into, you know, grid automation system. And we're trying to develop a control, a monitoring system or a control center that is supervised and is almost automatically supervise the health status of each component. the residential sector, there is a lot of things going on that involved AI and involved data. First of all, smart metering, the advanced metering infrastructure, but also smart control, smart appliances, but also, you know, opportunities to retrofit buildings. One thing that France has done, for instance, have used satellite images to identify buildings with high sort of potential retrofit. So they identify buildings that could be retrofitted, they could reduce their energy consumption. And so if we start looking at the potential for retrofit in Europe, well, we can see that there is millions of buildings that across Europe, extended Europe, Europe 28, they could be retrofitted to reduce the carbon footprint. To do so, to evaluate that potential, to evaluate how this potential could impact the grid, we use several data-driven and physical techniques like digital twinning or optimization in buildings in order to reduce their consumption, but also adapt to a higher integration of renewable energies. And this is one work that we have published. At community level as well, you know, at community level, we are using data in order to forecast the energy demand, the heating demand, but also to evaluate and assess the best mix of generation in order to satisfy that demand. And this is something that we have done quite comprehensively in several occasions. Like this is a university, UCD University. We have worked the last few years, we have worked to try to optimize at community level the energy demand of a set of district of buildings. Buildings, as I said, you know, they could also benefit from forecast energy. So they could adapt to weather, they could adapt to demand response events. What does it mean, demand response? It means that the building energy profile can adapt to the integration of renewable. Let's say when there is a lot of wind, the energy prices are very low. So buildings and buildings energy systems, energy management system in buildings can increase their consumption. They can store energy, or they can increase the consumption of the energy based on what is called the demand response event. There are several, but the crucial and important part, because demand response and demand side measure could work effectively in a building context, is forecast. This is a sort of how the forecast is going to work in terms of, you know, sensoring, ingesting sensoring, weather data, and, you know, how the building can adapt to demand response signal in a sort of dynamic way, forcing load or shifting load based on the demand response signal from the transmission operator like AirGrid. And this is some work that we have done using the neural network. So in conclusion, what is missing in this picture? Well, we'll need data. Data is the base of a machine learning model and artificial intelligence, and more data set and data set structure that allow us to ingest this huge amount of data, allow to model and forecast and evaluate this data is something that, you know, especially computer science cannot get enough. But the decarbonization of our society is it's a sort of interconnection between, yes, energy system, energy efficiency, but also data. Data is one of the most important parts, because if we can integrate data with the physical asset like solar panel, wind turbine, buildings, generator, and so on, then we can optimize the use of the resources. And this is in terms of AVI, you know, what I'm interested in terms of research areas of collaboration is this smart building and active building, demand response, deployment of AV, and also, you know, all these machine learning techniques that are supporting the decarbonization of our society. Well, basically, in my 30 minutes, I just, this was my presentation. It's a sort of high level, but I wanted to just give you a glimpse of my type of research, or my type of sort of work. Are there any questions? No questions so far.
I have one question, Fabiano.
Yeah, go, Paul. Hi.
So I don't know. Sorry, I was a little bit late. You may have covered some of it before, but I guess for you know, a lot of these you know, things to be useful within you know, within a country or whatever, I think you need you know, a certain amount of legislation and encouragement, you know, at a governmental level, because you can understand that, you know, it's beneficial to, you know, charge an electric car at night or use electricity at night, you know, when there's less when it's less carbon intensive. But how do you really encourage that? I think it's, you know, I think it is very much dependent on government legislation. Is that just kind of outside of the scope of what you're thinking of, or is it, you know, important to include those types of organizations in you know, in the cluster, etc.?
Yeah, no, that's a very relevant question, Paul. Of course, policy is a sort of important. It's an important matter when we talk about decarbonization, and policy need to drive the decarbonization. However, you know, there are already policy in place. I mean, and policy will come true because we, as a globally, as a sort of, so Europe, we are trying to be carbon neutral by 2050. So this is not something that is not, this is something that if we want or not, is going to happen. Now, this is on a long term. On a short term, you know, what the policymakers are doing are trying to subsidize and incentivize this sort of program. For instance, solar panel on the roof. Now Ireland is moving toward a more dynamic power system with demand response and demand side that have been rewarded. There are several demand response aggregators. So the policy is already in place. Of course, we'll need an evolution of the policy. For building now, we are working with SCI, and I'm working currently on SCI on smart buildings and trying to understand what will be the policy implication of the new technology. And also we're working in a project with energy communities, and how energy communities can contribute. So the policy are, unfortunately, are following the technology. They should be ahead of the technology, but are following. But it's important that policy-wise they are there, and they can really, you know, support this sort of. But we are lucky because the European Union is going toward that direction and is doing quite a lot of effort. Look at the Green Deal, for instance.
No, it just seems sometimes there's a lot of missed opportunities, you know, that could be easily realized through either policy or you know, lack of uptake from, let's say, the energy providers, ESB, etc. You know.
Oh yeah, they are big companies, and they are not really keen to sort of innovation, but it's normal, you know. They are the energy industry. It's an industry that is based on stability, reliability, and so it's difficult to adapt to a much more dynamic environment. Look at what happened in Texas a couple of years ago. That was a miscalculation because they are basically they're using a sort of more dynamic approach, but they basically caused a blackout, you know. So there is a big balance there, and yeah, we need to push toward them, but of course it requires time.
Thanks.
Thanks, Fabiano. Just kind of a follow-up question to this. As you were talking about the big companies not wanting or not ready to move, so like how much is AI or any of the projects which you mentioned dependent upon the infrastructure which a company or a country has to basically produce that data, and how can kind of you work together with AI without that huge amount of data, because the infrastructure is still building up in terms of producing the data. So yeah. Is that part of your scope, and what are your thoughts on that?
No, that's a very good question. Listen, I'm working now with a US provider, TSO, actually with a research institute. So the data is there. They have data. The problem is accessing this data. Me and my team it took us more than 1 year to install, to create an infrastructure to access a single repository of this for security reason, to access this data and start working on anomaly detection. So the data are there. Unfortunately, it's difficult to access. These companies are are legacy companies, so you need to be very, very patient. But the data are there already. There are in US, for instance, there is this company. There are
I think we lost your sound there, Fabiano.
Yeah. So, sorry, Fabiano, we can't hear you.
Hello?
Yeah. Sorry, we lost you. Lost your sound for a bit. Still not there.
You know. What about now? What about now? No?
Yep. Yeah.
Yes. Okay, so we are working with a company at the moment.
It's gone.
Maybe we can discuss this later, because I just see the time is also running out for the
yeah.
Okay. Thanks to you anyway. Thank you.
Thanks to you. Sorry about the
No worries.
Yeah, thanks, Fabiano. And thanks everyone for attending today. And just a quick reminder that we have a webinar coming up on the Empower program and safeguarding data that works for all. So that will be on next Thursday, and we'll also have our next coffee and talk from Priyanka as well. So hope to see you all soon. Thanks again.
Thanks, folks.